Hi everyone. I apologize about my voice, but I'll make this rather quick. In this section, we're going to verify trigonometric identities, meaning you have something that looks like an equation with a left and a right side, and what you want to do is you want to prove that the two sides are in fact equal to each other. To do this, we have several strategies. By far the most important is that you start with the more complicated side and you work on that. Other strategies are you're going to use your identities. You can use algebraic operations like combining fractions, factoring, and so on. You're going to work with the denominator. And if nothing presents itself, you can always try to write something in terms of sines and cosines only. But like I said, by far, this is the most important. So let's start with our very first one. Here, clearly, the more complicated side is this on the left. What I do is I draw a vertical line right underneath the equal sign. Now I'm going to work with the left side only. I'm going to try to simplify this and hopefully make it look like secant to the 4x. So first of all, yesterday we learned an identity, and the identity in fact said tangent squared x plus 1 equals secant squared x. So this is equal to secant squared x over, what's 1 minus sine squared x? Well, we have another identity. Cosine squared x plus sine squared x equals 1. If I subtract sine squared x on both sides, I get cosine squared x equals 1 minus sine squared x. So this is equal to cosine squared x. Now, what I have on top is secant squared x, which is 1 over cosine squared x. The denominator is cosine squared x. So look at what I have here. What I have is 1 over cosine squared divided by cosine squared. So this is 1 over cosine squared x times 1 over cosine squared x. So this divided by this is the fraction times the reciprocal. What I get here is 1 over cosine to the 4x, and this really, because 1 over cosine is secant to the 4x. So there we go. That's my identity. Okay, the next one, the right side has the more complicated part, so that's what we're going to start working on. Now, you have two fractions being added or subtracted to each other, meaning you're going to do a common denominator. The common denominator is 1 plus cosine x, 1 minus cosine x. Now, just like we did in the last section, I take this denominator divided by this. I have 1 minus cosine x times sine x. Minus, this cancels with this, 1 plus cosine times sine x. Okay, next I'm going to distribute the sine x here and here. So I'm going to get sine x minus sine x cosine x minus sine x minus sine x cosine x all over 1 plus cosine, 1 minus cosine is 1 minus cosine squared x. Now, some stuff should cancel here, and in fact they do. I get negative sine cosine, that's minus 2 sine x cosine x. What about the denominator? Well, I know that sine squared x plus cosine squared x equals 1, so 1 minus cosine squared x, if I take this to the other side, is sine squared x. So this is sine squared x. Now, more stuff will cancel. A sine x here will cancel with one of the signs on the bottom. So I have negative 2 cosine x over sine x. And what is negative 2 cosine x over sine x? This is negative 2 cotangent x, which in fact is exactly what we needed here. Just like magic. One more. So here it's debatable which one is more complicated. I would say to start with the fraction. To get rid of the denominator, or to work with the denominator, what we do is we multiply, and this is a trick that you can do all the time. If this is secant x minus 1, you multiply by secant x plus 1. Okay, so let's draw our line. Whatever you do to the bottom, you have to do to the top as well. So on the top, when I distribute, actually, I don't want to distribute just yet. I have sine x secant x plus 1 over secant squared x minus 1. Now, what's our formula? The formula is tangent squared theta plus 1 equals secant squared x. So if I subtract 1, tangent squared x is secant squared x minus 1, meaning the denominator is tangent squared x. Okay, we have some signs here, so let's switch this to sine over cosine. Sine squared x over cosine squared x. This divided by the fraction means we have the numerator times the reciprocal of the denominator. So remember, something divided by a fraction is the same as multiplying by the reciprocal. Now, one sign cancels with another sign. What we have is secant x plus 1 times cosine squared x on top. Let's distribute the cosine squared x now. over sine of x. All right, what are we going to do now? Well, look, cosine and secant are related. So what I'm going to do is rewrite the secant as 1 over cosine. 1 over cosine x plus cosine squared x over sine x. We're getting there, guys. 1 cosine goes with 1 cosine. So what I have now is this. Cosine x plus cosine squared x over sine x. Another trick we can do when the numerator has more than one term and the denominator has one term, we can split them up. Give each one a sign, so this will be cosine x over sine x plus cosine squared x over sine x. Now, this is my favorite trick of all time. Whoops, that wasn't the trick. Okay, this is the trick. So, cosine x over sine x is just cotangent x. That's not the trick either. Plus, what we can do here with the cosine squared, this is really cosine times cosine. So I'll write it as cosine x times cosine x over sine x. Now, if I just group this, that'll give me a cotangent. So I have cotangent x plus another cotangent x times what's left, cosine x. And look, that's exactly what we needed way up there. This is just a thrill. It's too happy face worthy. Okay, let's do one more. Clearly, we're going to start with the left here. And what we can do here is I have a cosine here and a cosine there. And I have a tangent here and some tangents there. So I'm going to factor out a cosine x and a tangent x. Here, if I factor out a cosine x and a tangent x, I just have secant squared x left. Minus, from here, I factor out the cosine x, so that's gone. And if I take out one tangent, I have 2 more left. Now, secant squared, tangent squared, that's an identity. And in fact, the identity is tangent squared x plus 1 equals secant squared x. So now, suppose I subtract a tangent squared x. I get secant squared x minus tangent squared x is equal to 1. So this whole thing is equal to 1. Isn't that wonderful? And here I have cosine x times tangent x. Well, what's tangent x really? It's sine x over cosine x. These go away, and I'm just left with sine x. My alignment here is horrible. I'll talk more about that in class. One more. This should say E. I pressed enter and it must have recalculated. Okay, so here I'm going to factor out a cotangent. And I have cotangent squared x plus 1. Well, what's the identity? Cotangent squared theta plus 1 equals cosecant squared theta. So this is cosecant squared theta. Okay, over here I have some cosines, no cosines here, but I have the potential of a cosine in the cotangent. Let's switch this into cosine x over sine x times cosecant squared x. X, never switch the angles. So what do we have here? This is cosine over sine. I can rewrite it again. That's like what my favorite trick. Cosine over sine is the same as cosine x times 1 over sine x, right? This is cosine over sine times cosecant squared x. Okay, what is this? Cosecant x. So I have cosine x, cosecant x, cosecant squared x. Finally, this is cosine x times cosecant cubed x, which is exactly what we want. All right. I'm going to skip this problem for now. So if on the homework, if there is one where you have to use a graphing calculator to test, just skip those problems. Otherwise, this is the homework, and it's going to be due on Thursday. See you guys then.